Welcome to the video lecture series of Vidyam Academy. Friends, we are discussing numerical on rotational dynamics. Today we will discuss question number 12 in your book. I'll read question. Somehow an ant is stuck to the rim of a bicycle wheel of diameter 1 meter while the bicycle is on central stand. The wheel is set into rotation. It attains the frequency of 2 revolutions per second in 10 seconds with uniform acceleration. Calculate number of revolutions completed by an ant in 10 seconds. Second, time taken by it for first complete revolution and the last complete revolution. Now we will see how to solve numerical. First we will try to understand what they are saying. I hope you can see the question clearly. So what is the data? Now first point is the diameter of that particular wheel. So in data I'll write diameter is equal to 1 meter. So that gives me a radius equals to 0.5 meter. Okay, then they are saying that the wheel is set into rotation. That means initially the wheel is at rest. If initially is wheel at rest, that signifies at initial time there is no initial frequency. That means initial frequency will be 0. Thereafter in 10 seconds the wheel reaches to the frequency of 2 revolutions per second. Okay, but what is the formula of omega? Omega is nothing but 2 pi n, and this is the situation after 10 seconds. Okay, so I am trying to find out final angular velocity. So 2 omega f equal to 2 pi n, but n is equal to 2. So omega f equals to 2 pi into 2, that gives me 4 pi. That is the value of omega f. So these are the data points. Okay, but now how to solve the equation? We have to understand kinematical equations. V is equal to u plus at. Very simple kinematical equation, but its angular form is written over here. V is the final velocity, so omega f, this is final angular velocity. U, initial velocity. Omega I, this is initial angular velocity. A, this is normal acceleration. Alpha is angular acceleration. T will remain as it is. Similar way, S is equal to ut plus 1/2 at square. That can be written as theta equals to omega I t plus half alpha t square. Here S is a displacement which is replaced by angular displacement, which is nothing but theta. First we will try to find out alpha. So I'll write formula omega f equals to omega I plus alpha t. So what is final velocity? Is 4 pi, initial 0 plus alpha t. Okay, so what is the time to achieve final velocity? 10 seconds. Basically we have seen that. Therefore alpha will be replaced by 10. So 4 pi equals to 10t. Correct? Sorry, alpha into 10. Okay, so what is the value of alpha? Alpha is equal to 0.4 pi. What is the unit of acceleration? That is radian per second square. Now we will try to find out total displacement. For that we will use the formula theta is equal to omega I t plus half alpha t square. So theta equals to, what is initial velocity? That was 0. So plus half, value of alpha is 0.4 pi, value of t is 10. So 10 square. Correct? So after solving you can write theta is equals to half 0.4 pi into 100. So this will become 50. So final theta equals to 20 pi. So what is the unit of theta? Theta is angular displacement, so it is denoted by a radian only. Now they are asking you about number of revolutions. To find out number of revolutions, we will use the formula total displacement divided by displacement in one cycle. Right now we have found that total displacement is 20 pi. So therefore number of revolutions equal to 20 pi. That is the total displacement divided by displacement in one cycle. In one cycle 2 pi will be covered. Okay, So number of revolutions will be 10. Okay, there will not be any unit for number of revolutions, it is a pure number. Now the next they are asking you about time for the first revolution. Once again I'll use the same formula. So to find out time, first we have to find out what is the distance or a displacement traveled by the particle in in first revolution. So in first revolution there will be displacement of 2 pi equals to initial velocity, angular velocity will be 0 plus half value of alpha, that is 0.4 pi, which already we have derived it, t1 square. Okay, so half will go to that side, it will become 4 pi equals to 0.4 pi t square. So pi will get cut out, so 4 divided by 0.4 equal to t square. So what, sorry, t1 we will write. So what is t1? T1 square will be 10. So what is the value of t1? It is under root 10 seconds. Finally, they are asking you about the time required for completion of 10th cycle, only 10th cycle. They are not talking about total time. Total time is 10 seconds to complete 10 revolutions. Okay, but we have to find out what is the time between 9th and 10th cycle. Okay, so for that we will require 9 cycle time. Okay, so once again we will try to find out time for completion of cycles from 1 to 9th. Once again we will use this formula. But what is theta? Theta is displacement during 9 cycles. So 9 into 2 pi, this will be the total displacement. So initial velocity will be 0 plus half value of alpha 0.4 pi into t9 square. So this will become 36, right? 36 pi equals to 0.4 pi t9 square. So pi will get cut out. 36 divided by 0.4 equals to t9 square. So what is the value of t9 square? Equals to 90. So what is the value of t9 only? It is under root of 19, which is equals to 9.49. So right now you have value of t9. Okay, so as I have written over, so time required for completion of 10th cycle only, total time, that is nothing but 10 seconds minus time of 9th cycle, that is 9.49. So 9.49, which gives me 0.51 second. Okay, so in this way we have completed numerical number 12. Thank you.